Doug Sillars. Thanks everybody for coming out. It's always hard when it's the last talk. You never know if everyone's just totally burned out after 2 days of awesome talks. So I'm glad so many of you made it to this last talk. I appreciate it. I'm going to talk about how to make images and video fast for your website, for your mobile app, for anything. And the great thing is I'm currently working as a digital nomad through Europe, and so I get to put up pictures of all the cool places that I've been because I'm talking about images. This is Three Castle Head in southwest Ireland. So let's just get started. A little bit about me. I do freelance developer relations. I help people with performance, whether it's web or native. I do workshops on images and video. I wrote a book about high-performance Android apps, and if you're interested, you can download the PDF. So I'll put the slides up later, and I'll tweet them out so you guys can get a hold of that. And if you ever have any questions or you want to talk about images or video or performance, I'm the only Doug Sillars on the internet. So I'm really easy to find. So feel free to reach out. So before we start talking about how to optimize images, this is first cliff walk in Switzerland. And so how many of you sort of get butterflies in your stomach thinking about walking across this walkway that's nailed onto the side of a mountain? I see a few hands, I hear some laughs, right? Yeah, it's totally terrifying. My 6-year-old decided to jump the whole way, so it rattled. She was trying to freak out her brothers and sisters, and it worked. But interestingly, Ericsson did a study a couple years ago, and they put sensors on people's heads to measure stress responses to different stimuli. And they found that queuing up in line raises people's stress. People get a little worried when they have to stand in line. When people think about standing at the edge of a cliff, just like all of you who raised your hand, they get nervous. It raises their stress response. But interestingly, a slow mobile experience is more stressful than standing on the edge of a cliff. Right? So that feeling that you were all feeling about 2 minutes ago, if your mobile app is slow, that's what your customers are feeling. And that's not what we want our customers to be feeling. We want our customers to be happy and then pull out their credit card and buy lots of stuff, right, in general. So we don't want our sites to be slow. Google found that a 3-second delay causes 53% of people to abandon a mobile site. Another study found half a second of delay makes your customers more frustrated and less engaged. Amazon and Walmart, and this study is from 2001, like before mobile, this is desktop. They found every 100 milliseconds causes them to lose 1% of their revenue. And then, of course, the best study of all is 4% of mobile users admit to throwing their phones when there's a slow mobile experience. So what can we do to speed up our mobile experiences? And this is from the HTTP archive. And so the HTTP archive looks at 500,000 websites. It's now 1.2 million websites every 2 weeks, both on desktop and on mobile. And if you look, images, 50%, video, 25%. Now, most websites don't have video, but the sites that do have video, it's so much video that it skews the average. Just like if Jeff Bezos came in and sat in the back over there, our average salaries would all be like $150 million a year, right? Okay, so what can we do to make images smaller? Like, we all have cameras, we all have these smartphones that take beautiful images. I was in Porto, Lisbon last week, and I took this beautiful picture with the phone that's in my pocket. It's 7.9 megabytes. And obviously we wouldn't put this up on the web because this would take forever to download on a mobile device. So I thought, I always like to kind of localize the talks that I give. And so I went and I took a photo of Oslo this morning. I'm from Seattle, so like this isn't a dig on you guys, right? I'm used to this. This is home to me. But what's interesting is images can compress very, very differently. And this image, being monochromatic with the same camera, is less than half the size of this image, right? Because this is super colorful and really, really awesome. And this looks like Seattle. But what can we do to optimize the images? Because if you're building a website, come visit Oslo, that isn't going to be it, right? You're going to pick a picture in summertime when it's beautiful. Lighthouse is a tool. It's in Chrome DevTools. If you're not using it to look at your web pages, you probably should. It has 4 image optimizations that I'd like to talk about today. the quality of the image, the format, the sizing, and then lazy loading of images. And when you run a Lighthouse audit of your web page, you get a score between 0 and 100. 0 is bad, 100 is really, really good. So you can get Lighthouse from web page test. Does anyone here use web page test? I see a lot of nods, hands raised. If you haven't used it, check it out, webpagetest.org. You test your web page. You can test it on real devices. They're actual real devices that it runs on. They're not emulated. You can set up your own private instance with devices if you want to. And you can test your web page in audit to see how it loads. The HTTP archive runs on top of web page test. So those 500,000 sites that are tested every couple weeks run web page test and their Lighthouse audit. So I can look at all of the top web pages that are being run and see how they're performing with these 4 simple image optimizations. And that's what I'm going to do now. So I'm going to look at how the web today is dealing with these 4 optimizations and what would happen if everybody used these optimizations to make their web pages faster. So if we start with image quality, Lighthouse recommends that you save all of your images at 85% quality. And so 85% quality this is a lossy compression, so you're removing pixels. 85% quality means you're lowering the quality to 85%. Now what's interesting is 85% in Photoshop is different than 85% in other tools. So here I'm using ImageMagick, setting a Riga image to quality 85 and saving it. You can use a tool like Cloudinary, which is a cloud-based tool. You upload the full-size image and you just put Q85 in the URL and it generates an 85% quality image for you on the fly. So what does that look like? Here's this image from Riga from this summer, right? This is the sort of image that you put on a web page saying, come visit our city. And it was 3.6 megabytes on my phone. When I save it at 85% quality, it's half the size, right? So that makes a lot of sense. This is easy. No one can tell a difference between those 2 images because the number of pixels that are lost putting it up on the screen, you can't tell the difference. So this is great, right? We just made this image half the size. Let's see how people are doing this on the web today. If we look at 500,000 websites, we see that a full third of the internet is not saving any of their images at 85%. They score a 0. So those images, those websites could be really optimized just by changing those images and saving them at 85%. We can look at how much, because Lighthouse estimates how much faster the page would be on 3G if you made this optimization. And then looking at all of these websites, I found that the median page would be 2.8 seconds faster and use 420 kilobytes less data. Like, that's a pretty substantial improvement on mobile if you could just save the images and you make your web page that much faster. But can we do better? What if we save the image at 50%? Like, it's smaller, it's again half the size, but if you start looking, if you look really carefully, there's artifacts and things like that. You can't really tell, but when I go to 20%, like, it's pretty obvious. You can see the banding in the skies, right? This would not be an image that you'd want to put up. So we know that 85% is good. We know 20% is bad. But wouldn't it be really cool to find like the optimal spot in the middle there without having to like manually look at all those different images? And there are tools out there that'll do it. Google has a tool called Booter Owly. And then there's a structural similarity is another tool that does the same thing. And what this does is it lowers the quality to human eye perception. So it goes down to where the human eye can't tell a difference and then saves the image at that point. So this is an open source tool called CJPEG, and it creates an image for you that's optimized at structural similarity levels. If you use Cloudinary, you can set QAuto, and it just generates it for you on the fly, and you can use that URL. And when I do that, the image goes down to 1.46 megabytes. It was 1.87 before, so I just saved another 400K, right? That's a pretty good savings. We're making this image smaller, right? It's somewhere, about 75%. So what I can do is I can run these different images through web page tests, and we can see how much faster they are. So here is web page test. I'm testing on a Motorola G4. The guy who runs it, Pat Meenan, has a bunch of devices in his basement in Dulles, Virginia. And they're next to the Christmas decorations and the furnace. Like, seriously, there's a blog post. You can see it. But if you run it on 3G, you can see the full image takes 21 seconds to download. Structural similarity goes down to 9.5 seconds, right? We've made this a lot faster. But we can still go faster because we have 3 more optimizations to go through with these images. The next one is image format. So these are all JPEGs, and if you look at the different images on the internet today, most of them are JPEG, and on average, JPEGs are the largest format that are out there. There was a tweet, I believe last month, JPEG just turned 26 years old. So JPEG is probably older than some of the people in this room, right? It's a format that's been around a while, and so there are newer formats that have better algorithms and better compression because they're newer formats. But before we get to that, let's talk a little bit about scalable vector graphics, or SVGs, because as you can see, they're really small. And so we should look to see where we might want to use those. Vector graphics are awesome because they're shapes. You put a bunch of shapes into XML, and they're infinitely scalable. So this is the same vector graphic of the Twitter logo, except for this is PowerPoint, so I had to take screenshots of the SVGs to put them into PowerPoint because there's no SVG support for PowerPoint. But that's the same image. It looks great no matter how much you stretch it. But you can do bad things with SVGs too. So I found the Facebook logo on a web page in Brazil. And you can open up the XML, because it's XML. And if you look, I enlarged what's down here at the bottom, and it says Adobe Illustrator, and there's all this metadata. And then you look at the little thumbnail there. And what happens if you save an SVG in Adobe Illustrator is it adds, in this case, it added 1.3 megabytes of extra data. And it's really easy to do. You open up the XML file, you highlight it, you hit delete, you hit save, and you're good. You're good to go. And it's 900 bytes. So I guess the moral of this story is test it before you push it to production. This website had 5 SVGs over 1 megabyte each. Should have been about 2.5 kilobytes. So pretty easy to fix. Obviously it's XML, so you can gzip it or use Brotli, which is just another compression algorithm, and you get it down to under half a K. Really awesome. So if you can use vector graphics for really small images, you can inline them into your HTML. They're super small, they're infinitely scalable. You should really look at them if you can use them. But let's look at WebP. WebP, you can see they're on average about half the size of JPEG, and WebP is about 7 years old. It's a Google format. It's a newer algorithm, so it compresses better. But you might be saying, but Doug, it's a Google format. What kind of support do I get? And it used to be that it was just Google. But look, right? That actually happened on October 2nd. This is just a month old, right? It's just launched last month. But if we look in the notes, Safari and Firefox are experimenting on it right now. So it may be that by early next year, WebP is a format that will work on almost all modern browsers. And at that point, we're already at 73%, but maybe, adding those 2 more browsers, it makes a lot more sense to start looking at that. What happens if I take my image and save it as WebP? From 1.4 megabytes, we're down to under 1 megabyte, right? Shaved off another 400 kilobytes. 9.4 seconds down to 7 seconds, right? We're getting faster and faster loading this image. Obviously use the picture tag, serve the WebP to the browsers that take it, have the JPEG as a fallback, and always have an alt tag for people who don't see images or won't see the images. If we look through the HTTP archive and see who's using these alternative formats, not a lot of sites are. 2/3 of the internet are not using these alternative formats. 67% fail this best practice. If this best practice were implemented from those 67% of sites that aren't doing it, we're looking at 4.1 seconds faster on 3G and about 600 kilobytes less data just by changing the format of these images. So again, another huge opportunity to speed up your web page just by changing the format, saving your images in a new format. The third optimization is sizing, and this is probably familiar to a lot of you. It's, responsive images. You want to resize the images for the devices or the screens that we're looking at. So as an example, here's a church in Serbia. It's 12 megapixels. I started at 1.6 megabytes. I do all the optimizations we just talked about. I have it down to 800K, but it's still 12 megabytes, or 12 megapixels, excuse me. So what happens when you serve a 12 megapixel image to a mobile phone, right? What ends up happening is you download 13 megapixels, you display 500,000 pixels, and you throw away 12.5 million pixels. And so what ends up happening for low-powered devices is the phone downloads all the data, 800K, that could take forever if you're on a slow network connection, and then it has to throw away 96%, I haven't figured out the math, but a huge percentage of the data ends up just getting thrown away and never used. So it's sort of a double taxation on these really slow devices on slow networks. It takes a lot of processing power to throw away all those pixels. And the best analogy I can come up with this is like when you buy something from Amazon and you open up the box and there's like 12 meters of brown paper and you pull it all out and you find out that your kids ordered like 2 pencils, right? I mean, it happens to all of us. We shouldn't be doing this to our customers. Like Amazon, if they want to do that to us, they can do that, but we shouldn't be doing that to people trying to get their images on mobile apps or on the mobile web. But how do you resize this image for all the devices that are out there? These are the Android devices that hit Akamai in one day about a year ago. The size of the box is how many devices, the quantity of each device. So these are all Samsung S7s and S8s. The color is how fast the CPU is. So you can see we've got a bunch of fast devices here, but as you reach the event horizon over here in the bottom right-hand corner, there are a lot of really slow Android devices that don't have a really big market share. So how do you optimize the images for all of those? And this is responsive images. So one theory behind responsive images is you generate a different image, a set of images that are all 25K different in size. And so I used a tool that generated a bunch of different sizes for me. I find the optimal size for my phone, and I'm only throwing away 100,000 pixels now, as opposed to 12.5 million. So I've made a huge improvement here. There are a bunch of tools that will do this for you. This is responsive breakpoints. There's a GitHub repo if you want to put this as part of your automation as you're uploading images. But I basically said, set the images between 200 and 1400 width, make them 25 kilobytes apart, and give me 20. And I got some code that looks like this, and I'm using Cloudinary again, and you can see that I just set the width here, and it generates a series of different images. But I've got that set up on the web page, so let's check that out. So this is the web page, and as I shrink the screen, you'll see different images pop in, and so you see a difference. Every other image is sepia, so you'll see 25 kilobytes will go from color to sepia as I go smaller and smaller. So and as you can see, there are really small jumps here when the images are large, because 25 kilobytes isn't that many pixels. But now, this is the optimized image for a really small screen. It's like 25K. This one is 200K. We've optimized it for every single device without wasting all of those pixels. The other cool thing about Cloudinary being a cloud-based tool is I set every other one, the sepia parameters actually in the URL, and it's doing that on the fly for me too, which is kind of fun. But if we look at the speed, I've now optimized the size of this image for a Motorola G4, right? So now the file size is now down to 121 kilobytes. It's downloading in 2 seconds. So it's optimized for the format, it's optimized for the size of the image, and it's optimized for the quality. And now it's just 120 kilobytes from 3.7 at the very beginning. And it's 10 times faster to download. So that's great. If we look, responsive images, this is sort of, I think, the mobile first idea, right? Resize the images. And if we look, about 60% of the web is doing this 100%. They're doing a really good job. But, a fifth of the internet is still missing this, right? We can still resize the images so they look great on mobile devices and resize them so we're not wasting all of these extra pixels. If those sites that were failing fixed it, the median site would be 2.7 seconds faster, another 400 kilobytes of savings, right? These optimizations have pretty big savings, for the sites once they optimize for them. So these first 3 optimizations are really based per image. So these are all like optimized for quality. Do this for each image that you have. Lazy loading is now more of a site or an app thing to do. And so the idea behind lazy loading is you've got this website with 6 or 7 images on it. 6 images, I should learn to count. And what you do is you only load the images that are going to show up on the screen at load time. So instead of loading 6 images while this page loads, you're only loading 2. This page is going to now load faster on the initial load time. And then you just add a little bit of JavaScript so that when the customer scrolls with the intersection observer, that these images are lazy loaded when the screen pops into place. If we look, 60%, again, not doing this at all. 20% is doing this right. The sites that aren't doing it could be 3.5 seconds faster on 3G. That's the median speed improvement, 500 kilobytes less data, right? So again, huge improvements if you decided to implement this. And so what do you do instead of having an image there? What do the customers see? And what a lot of sites have been doing and is they use preview images, placeholder images. And so you've seen this in Median, you've seen this on lots of different sites. Google image search does this. So if you search for cats in costume and you slow down the network speed a lot because it's really hard to see on a fast connection, these placeholder images come in and the color matches sort of what ends up on the screen. So the bunny rabbit cat is pink and the dragon cat is green and the pumpkin cat, I'm not sure, is orange, right? So they sort of, as a customer, you know that an image is coming and then it pops into place. And so our customers kind of know that when they see something like this, an image is coming. It's also great because the page is completely laid out. There's no, like, you don't have the text flying around as images pop into place. If you want to go a little bit fancier than just using a solid color, there's a library out there called Squib, and it generates an SVG with like 4 vectors of your image. So this is waterfalls, and you can see instead of just being green, there's sort of like this impression of what's going to come. And this is an SVG, it's 900 bytes, you zip it, it's 400 bytes, you can just inline it into your HTML as a background image, and it looks really, really great. So lazy loading is really cool. You can do it with, there are tons of JavaScript libraries that will do this for you. Just go out on GitHub, look for lazy loading, you'll find 20 or 30 libraries that will help you do this, or you can write your own. It's not really that difficult. But what would be really cool is if the browser would do this for us. And so in Chrome Canary, there's an experimental flag that does lazy loading for you. And so this is a web page, this is the desktop view, and I've just shrunk it down so you can see 1, 2, 3, 4, 5 views. And these are viewports as you scroll down. And so when I load this page in Chrome today, what you see is all the text loads in, and then placeholder images and images. You can see the text is still flowing down for each screenshot that I took. You can see that the placeholder images kind of come in weird. You see the cow image is already loaded when the images up here haven't loaded yet, right? It's loading images way down at the bottom of the page, and your customers are like, where are my images at the top? Why is it loading these images all out of order? So that's sort of what you see today on the web. When you turn on this Chrome flag, what happens is it requests the first couple bytes of each image. So it gets the size, and it lays out the whole screen, the whole page, almost immediately. So it's all laid out. And then you can see the full images load in order from top to bottom, which is what we expect to have happen. So the browser now knows where all the images are on the screen, and it can request them in order from top to bottom. So this is really exciting, because if you can get this done in the browser, it makes it easier for all of us, and it'll make our pages load a lot faster. I haven't looked at it for about 5 or 6 weeks. When I first looked at it right after it launched, it's still slower than that because it's making a couple requests for each image. It has to do a partial request and then a partial request. But as this evolves, it's still an experimental flag. Hopefully this will get faster and they'll be able to improve on it. And this will be something that's just in browsers. And wouldn't that be nice for all of us, that this is taken care of for us? So those are the optimizations that are inside Lighthouse. But I'd like to talk about a couple more. And I'd like to talk a little bit about animated GIFs. We all love animated GIFs. This is my goat, Nora. And we need more goats on the internet. So I made a GIF, right? The original movie was 1.4 megabytes. And when I turn it into an animated GIF, it's 3.8 megabytes. We're going the wrong way. And the reason for that is animated GIFs. Like I was talking about how old JPEG was. GIFs are from the 80s. So what these GIFs actually have no compression through the time. So it's actually a bunch of static GIFs that it just flips through it, whatever your frame rate is for your animated GIF. And so what can we do to make them smaller, right? We don't want to send down a 3.8 megabyte animated GIF. And if you have a bunch of these, you can see how your page just blows up like crazy. Well, if I make this an MP4, GIFs are 256 colors because it was from the 80s. I tell my kids that the 80s only had 256 colors, but they don't believe me. I strip out the audio channel because it's a GIF. It's silent, right? So when I do that, I get it down to 250K. And then you can make it a video tag, right? Video, loop, autoplay. On mobile, you have to add muted. And that's so that when you're browsing on the web in a meeting, the video doesn't play really loud and you get embarrassed that you're browsing the web when you should have been paying attention in the meeting. So autoplay and muted both have to happen for video to autoplay in Safari and Chrome on mobile. The problem is the browser's really smart and video files are generally big, so these are always the last thing to get loaded. So if you need this at the top of your page, this might actually delay the loading of it showing up. In Safari today, you can actually put MP4s in this picture tag. So you can actually put the GOAT MP4 and it'll, with all these parameters, and it'll loop for your Safari users. You can have an animated WebP for your Chrome users, and then for everybody else you have the GIF. And 3.8 megabytes, 3 megabytes for the animated WebP, 250K, your Safari users will really thank you. That page is going to load way faster than it will for everybody else. So it's something you can think about if you're looking at animated GIFs. And so animated GIFs are a really nice transition to talk about video. And what can we do to optimize video on the web? Video is really hard because image files, we've been talking about a couple megabytes per image, but video files it's an order of magnitude larger. Video files are ginormous. And when video is slow, people get frustrated. If a video doesn't start, people get frustrated. And when people get frustrated, they throw their mobile phones. That's where the picture comes from. So what do people look at when it comes to delivering video? There's 3 metrics that are very important for delivering video. The first one is, did the video start playing? Did the video stall after it started playing? And did it look good? These are the 3 primary metrics that are in most analytics software for video. A study from Q1 of this year from Conviva, which is a major analytics company for video, found that 14% of all video didn't play back. Could you imagine if 14% of web pages didn't load? We'd all be out of a job. We'd all be fired. But 14% of videos don't play. They either fail to start or the customer abandons them before the video starts to play. And this is pretty bad. It ends up being 2.4 billion video plays in just Q1 of this year. Failed to play. About 800 million hours of video were lost because it just never started. So what's going on here? What's happening? Let's start with this 400 million, the 2% that failed to start. What's happening there? So I went through the HTTP archive, and there were a few 404s, there were a few 500s, sort of the things you expect, but it was only like 0.2%. I think what a lot of it is this, right? Geolocation. And so I'm an Amazon member, and when I fire up Amazon Video, it says, oh, you're not in the States right now. You can't watch all of these, but here's what you can watch. And it takes away the whole step of like clicking through and finding out, oh, no, you can't watch it. They tell me ahead of time, you can't watch it while you're in Norway, but when you get back to the States, you can watch it. The great thing about that is I didn't have 231 requests and 3.1 megabytes to tell me that I can't watch it. Oops. It didn't take 19 seconds, but they've got like they keep sending a ping back to say, oops, like that it's not playing back. So that's just because that took a long time to get the screenshot. But this is kind of a horrible user experience. It's better just to let people know in advance that these videos aren't available where you are. The browser already knows. But what about the 2 billion where people abandoned the video before it started? Why are people giving up? They press play and they're waiting. And it doesn't start. Akamai did a study, and they found that everybody will wait 2 seconds. You can see that the abandonment is like nil at at 2 seconds. Everybody will hang out for 2 seconds. But for every second afterwards, you lose about 6% of your customers. So you use 6% of your customers at second 3, 12, but it depends on the type of video. Short videos, people abandon a lot faster. So if you click on a video about a cat in a shark costume on a Roomba chasing a duck, after about 3 seconds, you're like, what? And you give up, because there are probably better things you could be doing with your time. But if you're gonna watch a movie or a TV show, you're already setting aside half an hour to 2 hours of your time. You'll wait 15 seconds for the video to start. So people are a little more willing to wait for a long play video, as you might expect. But what causes these delays? What can we do to speed up what's going on? So this is a screenshot of the packets. This is a packet capture from a mobile app. And this is the ad downloading. You can see the throughput. And then this is the ad playing back. And these are just analytics. These are packets with analytics. And literally the analytics here, because they're sending over port 80 so I can read them, it says they've watched 25% of the ad. They've watched 50% of the ad. They've watched 75, they finished watching the ad. And then the app's like, oh yeah, they wanted to watch a movie. And it starts downloading the movie. The problem with this, of course, is you end up waiting 10 seconds with a spinner because the video isn't there yet. The network's free right here. Why did they download the video while the ad's playing back? If they've had 15 seconds of download, the ad finishes and they go right into the TV show or the movie. So if you can preload the movie, if you've got time, and they had 30 seconds of time here to preload the movie so it just goes straight into the movie. You won't lose those customers. But you have to be careful with video preload. This is a web page. You just go to www.thiswebpage.com. This is the web page test, waterfall. And there's a video, and then they have set preload equals auto. Preload equals auto means it will download that whole video whether you want it or not, customer. And you can see that. At the very end, it's downloading all of these giant video files. In fact, it was 23 megabytes of video files, whether you wanted it or not, on your mobile device. So, when you're on a web page and you see a video, but you're on your phone, you're like, yeah, I probably won't click that because I don't really want to watch it, or I don't want to waste the data. These guys decided for you. You get to watch it. Just think about their server costs. Every time somebody hits their page, their server is delivering 25 megabytes of data to every single customer. That can be expensive for the server costs as well. Another thing to look at is background video. So studies have shown that having background video on your web pages increases your engagement by 80%. Now I know this was a company that offers background videos, so take that with a grain of salt. But people really like seeing this sort of thing, right? You're like, oh wow, my kids would love going to this place, right? So this video was on this web page, and I started looking, and the video is 5.3 megabytes. It's large, but it's not outrageously large. But what's interesting is they didn't strip the audio channel out of this video. So they're downloading an extra 250 kilobytes that nobody ever hears because background videos are silent. So if you're going to send down a silent video, whether it's a GIF or a background video, remove the audio stream to make them smaller. It'll download faster, it'll show up on the screen faster, and your customers have no idea. Super easy thing to do. If you're going to download a background video on mobile, you can see the videos being downloaded on mobile, but your CSS blocks it because of the width of the screen and just shows a placeholder image. You just downloaded a whole bunch of video that nobody can see. And I just did this earlier today, and the Chrome bar came up and showed that there was a video playing. It showed the video was playing back, but it looked like this on my phone. So it was really confusing. Where's this video that's playing on my phone? I don't see it. It's because it's blocked. So if the viewport isn't going to support the video, probably shouldn't download it. Save a lot of data. This is another one with a background video, and on this webpage you will never see this background video unless you sit there for a really, really long time. So let's look at this video and see what they did wrong. The first thing that you learn about this video is Bob Ross is not just a painter. He's also a photographer. But this video is 33 megabytes in size, served on a web page. It's 27 seconds long. It's 2,500 by 1,200. Like, this is just like raw output from the camera, I think, right? It's 10 megabits per second. So first best practice is resize your video to a reasonable size for desktop and mobile. Pro tip, if you rename it to 720p, that doesn't actually re-encode the video. It's new, but it's not 720p. But you can resize it. And if you make it 1080p, it's 8 megabytes, 720p, it's 4.3 megabytes. It's large, but this is a little more reasonable to serve on a web page. So look at what you resize the video so it's appropriate for desktop. And if you can, do a little JavaScript and serve a smaller one to your mobile users. Don't serve the 8 megabyte one, maybe serve the 3 megabyte one. It's a little faster. This video is also served to mobile, but it completely fails, as you might imagine. It never loads. The next thing to think about is third-party video content. TED Talks. Everybody love TED Talks? Right? They're really awesome. They're a great way to learn, and it's really easy to share them. There's a button to share, and you get one line of code. That's going to be easy, right? What do you think happens when you add this one line of code to your web page? Well, it turns out this is a stream, and it downloads 118 requests and 32 megabytes of data on desktop. Now, it's a stream, it's adaptive bitrate, so if you do this on a mobile device, it'll be a lower quality video, but it still downloads the entire video when you just load the page. So YouTube does the same thing. YouTube doesn't download any video, but it adds like 700 kilobytes of JavaScript to get ready to play back the video. So when you add a third-party video, you should audit. Anytime you add a third party to anything, you should probably audit to see what it does to your web page, to your mobile app. But let's talk really quickly about video streaming. And what video streaming happens is there's a bunch of different bit rates. Since you have bit rates that are appropriate for really fast connections on big screens and all the way down to really slow connections on really small screens. And so you have this manifest file that lists them all. And that gets sent down to the player. And the player says, I'll pick a stream. It starts downloading the different video segments. And a video segment is usually a segment is usually about 2 or 4, sometimes 10 seconds long. And so it just can play those back one after another. And it starts downloading them, and then ideally what will happen is the video will start playing on your device. But what happens, and then after the video starts downloading, the player can estimate what the network speed is and change the bit rate. So if it downloaded a really low quality, it can go to a higher quality video and you get the right bit rate. And you've seen this, like when you start watching a movie and it's really pixelated for the first couple seconds, and then it snaps into something looking really, really nice. That's what's happening here. It starts off with a really low bit rate. Why would it start with a really low bit rate? Well, the reason it starts with let me just hop ahead. The reason it starts with a really low bit rate is it doesn't know what to use, and so the player always just picks the first list in the manifest file. So this is the manifest file. And if it starts with a high bit rate stream, this one's 1.4 megabit per second. If it starts with a high bit rate stream, it starts downloading and it takes a long time to fill. And we all know that if it takes a long time, your customers will abandon. So the video doesn't play. And so the player then has to switch to a lower bit rate, and then the video starts playing. So a lot of websites start with the lowest quality bit rate because it fills up the buffer fastest. The video starts playing right away. It may not look good, but the video's playing. And we know that getting it to play back is really important. So if you start with a really high bit rate, you end up with this extra step of where it doesn't work, and then you have to download the small bit rate and it starts working. And that's probably why a lot of people abandon, because it's taking a long time for it to start. The same study shows that in Europe, 4.3 seconds for videos to start up on average. And this is a really horrible number because this is desktop, this is mobile, this is in the city, it's out in the country, it's on fast devices, this is an average of a million different options. But like I said, to get the video to start up really fast, it makes sense to start off with, if these are all the different bit rates, start with this lowest bit rate. It will look poor quality to begin with. It'll jump to a better quality within a couple seconds. And usually the first couple seconds of video don't really matter that much anyway if they're pixelated. If you start with the highest bit rate, it ends up going down to the lowest bit rate, usually on mobile, because it can't handle like 8 megabits per second streaming on a mobile connection. And then you end up here. So you have this extra step, which is slowing down your startup time. Interestingly, Amazon goes with the Goldilocks approach. They pick one that's not too big and not too small. And the reason they do this is when you're watching a video with Amazon, you're already going to be sitting for 20 minutes, right? At least it's a TV show or a movie. And we know that people watching TV shows and movies will hang out a little bit longer. And so they decide to start off with a really good quality. It may take a second or two longer, but from time 0, it looks beautiful. And so that's how they're differentiating their video. When it starts up, it looks beautiful from the very start. And it may just sit right there at that video bit rate all along, and it looks great. We can actually look at these with web page test. If you start with the lowest quality bit rate, the video starts playing in this case, at 11 seconds. Right? You can see this is Big Butt Bunny. It starts playing right there. If we start at the highest bit rate, it's trying to download the highest bit rate. It's failing. It starts down the lowest bit rate. This video quality at 17 seconds is identical to that there, but it just took 6 seconds longer. So that's bad, right? We're losing customers when we do that. And this is sort of the Amazon approach. This video took maybe 2.5 seconds longer to load, but it's sharp and it looks better than this video. So like, this is just something to look at. Your mileage may vary. It depends what kind of experience you're trying to build for your users. But I would recommend starting with the low or the middle approach, just because you either get, this one, when you start at the highest, most connections are going to start off with low quality and slow startup. But if you start off with the lowest quality, it's going to start up quickly. Con is that the quality isn't that great. In the middle, you've got good quality, but it's not too fast, not too slow for startup. So it's kind of balancing everything. So if you look at the manifest file, this is another one. Well, this is the same talk, actually. And so what I found when I was testing this with web page test on 3G is, it starts off at this bit rate right here, and then it drops to this low quality bit rate and stays there for the entire video. And so it looked really pixelated, and it looked horrible for the entire TED Talk. And I was trying to figure out why, if I'm testing with 3G, so I've got 1.6 megabytes per second. Any one of these should work. Why did it stick with that lowest bit rate? Something was wrong with the manifest file. What were they doing wrong? If we look at the manifest file, they're saying that the first bit rate is 1.4 megabits per second. But if you look at the video, it's 600 kilobits per second. So they're overstating the bit rate, so the buffer fills up twice as fast, right? If the buffer will fill up twice as fast, it won't stall. This video will never stall. However, when they did this on a slow connection, it meant people were getting very low quality video. So again, there's this balance of how close do you want to get towards stalling versus having a really low or a good quality video. So if I go and I rewrite this and I match the bandwidth to the actual bandwidth for all of these going all the way down, so 64K to 64K, 180K to 180K, what I see, first off, is if you look at the bandwidth, I've halved everything, right? The y-axis has improved. I still drop to that lowest bit rate to start, but eventually, by the time the TED video has started, I'm back up to 600. This thousands is the intro to every single TED Talk, with the stars and the sound that we all know when a TED Talk starts. But it drops down to this low quality, and that still didn't make sense, right? I have bandwidth, it shouldn't drop to that lowest quality. And so I went deeper into the manifest files, and these are each segment that it's requesting. And you can see it's asking for a byte range for each one of these segments. And each byte range, it gives the time in seconds. So it's saying that this byte range is 5 seconds, this byte range is 6 seconds, this one is 0.12 seconds. But if you start looking at how many bytes, like the bytes to time ratio, they don't quite make sense. Like their math is wrong here. And so I spent a lot of time trying to figure out the exact math ratios, and I couldn't figure it out. And I said, screw it, let's just download the entire bumper in one file, 12 seconds. Just download the whole thing at once. And what I found when I did that is it stayed at that high bit rate all the way through. And so somehow they were writing their manifest file in an incorrect way, and it was forcing it to go down to these low bit rates and lowering the quality of the video. But by rewriting that file, it stayed at 600 kilobits per second, and then eventually jumped up to this 950. So when I started looking at this, it was serving it at a really, really low quality video. And when I got through auditing the way they were building their manifest files, I got it so that it was at a really high quality video. So the trick with this is this may stall more often. So I optimize this for quality and not for stalls. There's probably a sweet spot somewhere in the middle where you still get really good quality and you minimize the number of stalls. So in conclusion, I thank you everyone for hanging out, for listening to this. When you're optimizing images, you want to optimize your images for quality, format, sizing. And if you can lazy load images that aren't on the screen, that's the best way to reduce the number of requests on your web page. It's like the fastest code is the code that's never run. The fastest download is the one that you never make. And when you're dealing with video, only download video when it's displayed. If it's a silent video, strip out the audio. Resize your videos for a mobile, so you're not sending down the giant videos. I did a study, again, with the HTTP archive. 20% of all videos on desktop and mobile are identical. So there are these 1080p videos being served to mobile devices, and that's just not ideal. If you're serving third-party content, you should audit to make sure it's not killing the speed and the download time of your web page. That goes for video as well. When you're streaming, start with a lower quality video so it starts up fast. And then if there's a balance between the bit rate that you're serving and what it actually is, that you can reduce stalls, but you can also reduce quality. So it's important to play with those parameters and find that sweet spot in the middle where you're reducing the number of stalls, but you're also making sure that your customers are getting really high quality video served to their devices. A bunch of the tools that I used: web page test, HTTP archive. Here are some of the image tools that I used as part of the analysis I was doing. And then Cloudinary helps you optimize images and video, so that's a cool tool if you're interested in doing that on the fly from a cloud-based service. So in conclusion, images and video can be beautiful and they can be delivered quickly to mobile devices on really slow connections. So thank you very much. I'd be happy to take any questions.